Okay, so the first thing we're going to do is practice long division. All right, because it's been a while since some of us have seen long division with a polynomial. So this polynomial you can actually divide using synthetic division. So I chose this because it was an easier one. We're not going to use synthetic division. You actually have to use long division because not every polynomial that you're going to be dividing will be divisible or dividing by x to the first power, which I'm talking about this one. So this is just our practice. So the first thing you're going to do is put this on the outside. And remember, if you're missing any terms, you should always put a placeholder in. So if you notice here, you're missing your x cubed. So we're actually going to put a placeholder in there. It might be insignificant, but it's important that you do put the placeholder in just in case. So you have x to the fourth here, 0x cubed, minus 8x squared, 11x, and then plus 1. Okay, so when you divide, you're actually going to divide the first term on the inside by the first term on the outside. So what is x to the fourth divided by x? X to the third. So we'll put x cubed up here, and then you take x cubed times x, which is x to the fourth. X cubed times 2x is 2x cubed. And when you would do this long division back in, I don't know, 7th period, said it was 5th grade, what did you do to the bottom row? Do you add? Do you multiply? What do you do? Oh, you subtract. So because we're subtracting a quantity here, you have to distribute a negative. So essentially what you're doing is changing all the signs on the bottom to the exact opposite. So if this was subtraction here, it would become addition because you're distributing the negative. So this becomes 0. Here you're left with negative 2x cubed, and then you bring down all the other terms again. Then you start over. You divide the first term, which is technically underneath the division, by the first term on the outside. So what's negative 2x cubed divided by x? Negative 2x squared. So you put it right here. You take negative 2x squared times x, negative 2x cubed. These should always be exactly the same. And then this is minus 4x squared. Bottom row, signs will change to the opposite. So remember, this should always become 0. If you don't distribute the negative, then it's not going to go away. So then you just combine these, negative 4x squared plus 11x plus 1, and then you start over. So again, not every problem, very few of these problems are going to be this long, but I wanted you to practice. So negative 4x squared divided by x, negative 4x. Negative 4x times x is negative 4x squared. Negative 4x times 2 is what? Negative 8x. Bottom row, signs change. Okay? This becomes 0. This is 19x plus 1. And this will be the last one. Can you divide 19x by x?
19.
Yeah, you get 19. So this is plus 19. So you have 19 times x, which is 19x, and 19 times 2 is 38. Bottom row, you change your signs, and you're left with negative 37. Okay, so you ask yourself, one of the questions that I always get is, how do I know I'm done? You take this term and you try to divide it by x. If it gives you a fraction, then you can't do it anymore. Okay, meaning you're going to get negative 37 over x, because you can't divide. So when you write this final answer, it would be x cubed minus 2x squared minus 4x plus 19. You do not write remainder. The last one is actually a fraction. It's minus 37 over what you divided by, which is x plus 2. Okay, so this is just a reminder of how you would divide polynomials. And the sole purpose of this is because now what we're going to do is we're actually going to use long division. But like I said before, not every problem is going to be this long. Okay, so when we're integrating using long division, okay, what you look for, okay, is the same degree or higher in the numerator. So if you think back to this, when we actually divided rational functions, this would be a slant asymptote. Do you guys remember that? Slant asymptote. You're not calculating a slant, but that's the whole idea. You're getting a slant asymptote. You can actually divide. So you're looking for the same degree or higher in the numerator. So when I look at these two problems, we're going to obviously start with number 1. But see how you have the same degree here, same degree here? This is not the same as what we did in the very beginning, where you guys would have a problem like this. Maybe it was the integral of, let's say, x squared plus 3 over x dx. This is totally different, because here you could split this up and divide here and simplify here. Now you have a quantity in the denominator. Totally different problem. Okay? So when you have a problem like this, when you integrate, your answers for the long division will either be an inverse tangent, okay, or a natural log of the absolute value of some quantity. Okay, meaning you're going to have something in here. So these are the types of answers that you will end up getting when you're using the long division. When we use completing the square, you will either get, and I'll go over it again, inverse sine or inverse tangent. So this way you know what you're looking for when you get your answer. Okay? All right, so let's take a look what happens here. So first of all, this a u sub is not going to work, because if I were to try u sub, maybe I would do a u sub from the bottom. U is equal to x minus 3, so then du would be equal to dx, but I have to get rid of this whole thing, so it's not going to work. So we actually need to divide. This is the same degree, so we're going to put x minus 3 on the outside and x plus 6 on the inside. Okay, it's the same degree. Now, there are no missing terms, so we don't have to put any placeholders in there. So you're going to take your first term on the inside, just like I showed you before, divided by your first term on the outside. And remember, I said these problems are going to be a little bit shorter. So what's x divided by x? Just 1. Okay, so 1 times x is x. 1 times negative 3 is negative 3. Okay, on the bottom row, your signs will change to the opposite, so you have a remainder of 9. Okay, can you take 9 divided by x? No. Okay, so you're done. So now what you're going to do is you're going to write these as two separate integrals. The first one is the answer that you got from the top, so it'd be the integral of 1 dx. That's from here. Then you have a remainder, and this remainder is 9 over x minus 3. Okay, so this is positive. This is my remainder, so I'm going to write this as plus the integral of 9 over x minus 3 dx. Okay, so this is my setup to start integrating. So this is really quick. I can integrate 1 dx. What is it? It's just x. So I'm going to leave this as an x, but I need to do a little bit of work here. So this 9 is a coefficient, correct? So what can we do with coefficients when we're integrating? Yep, bring it to the outside. Yep. Plus 9 times the integral of 1 over x minus 3 dx. Okay. So eventually what's going to happen is you'll probably be able to do this without a u sub, because you're going to get used to the process. But technically your u sub is what's in the bottom right here. So you're going to say u is equal to x minus 3. So if u is x minus 3, what do I need to get rid of? What has to go? The dx. So take the derivative, du is equal to dx, so I'm covered, right? So I have x here plus 9 times the integral of 1 over u du. I'm just showing you what I made the substitution for. What's the integral of 1 over u? Yeah, the natural log of the absolute value of whatever u is. So my answer is x plus 9 times the natural log of the absolute value. What's your u? X minus 3. And what do I have to make sure I do not forget with indefinite? Yes, plus c. Okay, so there's one variation, the natural log. Does anyone have any questions as to where anything came from? No? Okay, let's take a look at this second one. So here again, I'm still looking for my degree. In the top, the degree should be the same or higher as the bottom. Okay, so I'm good. So what I'm going to do is I'm going to set this up. What do you notice about the denominator? Is it missing anything?
Yeah.
It's missing an x, so you need to put a placeholder. Again, it might go away or I might not really need it, but you need to make sure that you have enough terms that will match up. So you've got x squared plus 0x plus 4 on the outside. And then on the inside, I'm just going to put x squared, 0x, and 0, just so I have placeholders. So remember, you divide the first term underneath by the first term on the outside. Okay? So what's x squared divided by x squared? 1. 1 times x squared is x squared. 1 times 0x is 0x. 1 times 4 is 4. What do you do to the bottom row? Yep, change the signs to the opposite. Okay, so this is gone, this is gone. and I'm left with a remainder of negative 4. Okay, up to this point, is everybody okay? Okay, essentially, this is negative 4 over what we divided by, which is x squared plus 4. This is my remainder, right? Okay, so this is where we're going to set up our two integrals. What's my first integral? Yep, it's the integral of 1 dx. Okay, here, describe this negative 4 for me. Has a name. We talked about it in the other problem. It was 9. Yeah, it's coefficient, so can I pull it to the outside? This becomes minus 4 times the integral. Now what's in the top of my fraction? A 1, and we have x squared plus 4 dx. Okay, so here's the deal. We can quickly integrate this, but now we need to manipulate this. Because I told you what your answers would look like in terms of inverse tangent or inverse sine for the next set of problems. Inverse tangent, the integral is 1 over 1 plus x squared, true? Okay, or it could be u squared or whatever it is. So what's the first problem with integrating this to make it look like inverse tangent? I have to do something to it. Yeah, I need to factor out a 4. I have to divide by 4. Okay, so when I do that, can I integrate this quick? Yeah, this is just x. So this is just going to kind of trail along as I'm doing the rest of the problem. Then this becomes minus 4, and I'm going to do this in multiple steps so you guys can see where everything's coming from. Eventually, you'll be able to do it all at once. So this would be 1 over, and I'm actually going to rewrite this because isn't it 1 over 1 plus x squared, just in terms of format? I'm just going to move these because they're both positive. I'm just going to switch their spots. So when I factor out the 4, this becomes a 1, right, this one right here, plus this is x squared over 4 dx. All I did was factor out the 4. Eventually, you guys will be able to do this all in one step, but I just want you to see everything. Where does this go? Where can I take? Yeah, send it out. So then I'm going to end up with 4 over 4. Okay? How can I deal with this? We want to rewrite this so that I can do a u sub. X over 2, the quantity squared. Okay. So you have x minus, and I'm going to write this as 4 over, and this 4 right here comes from here, just so you can see it. You can write it as a 1 if you want. Doesn't bother me. Then this is 1 over 1 plus x over 2, the quantity squared, dx. Okay, what does this allow me to do now? Yeah, u sub. So we're going to say u is equal to x over 2. Okay, so if I do that, we have x minus, this reduces to 1, the integral of 1 over 1 plus u squared. What do I have to get rid of? The dx. So I have du is equal to 1/2 dx. What's the problem? The 1/2. So we've got 2 du is equal to dx. So now I can put the du here, and where does the 2 go? On the outside right here. Questions so far? Okay, what is the integral of 1 over 1 plus u squared du? Inverse tangent. So we have x minus 2 times the inverse tangent. What's u? X over 2, and what do I have to make sure I throw on there? Plus c. Okay, questions so far?